Greetings everyone. In this video we will explore about the AI techniques. First, what is artificial intelligence? That is the study of making computers perform tasks that humans currently do better, right? So here we have different AI approaches. So these are the systems that act like humans, that's the robots or chatbots, systems that think like humans, systems that think rationally, and the systems that act rationally. Okay. So AI techniques are the methods and algorithms which is used to develop intelligent systems capable of performing tasks that require human-like intelligence. So we can see the common AI techniques are machine learning, that is learning from the data, natural language processing, system as NLP, understanding the human language, and computer vision, analyzing images or videos. Deep learning is the advanced neural networks. Next, we have types of AI, where narrow AI, that is a weak AI. This is AI that specializes in a specific task. For example, chatbots, face recognition, like that. Next, general AI, it is strong AI. So AI with human level intelligence, and still it is not yet achieved. And artificial superintelligence, that is the AI that surpasses human intelligence. That is basically it is theoretical. And reactive machines, AI that reacts but doesn't learn. For example, chess AI or rule based systems. These comes under the reactive machines. So here AI deals with a large spectrum of problems. So these are various day-to-day practical problems. So different identification and authentication problems with their applications in security, various classification problems resulting in decision making, interdependent and cross-domain problems. So AI techniques need to be built from a problem-solving perspective. So why do we need this AI techniques are for handling large volumes of data, for mapping various types of data, adapting to constantly changing scenarios, for knowledge building from the relevant data and data analytics, that is from data collection to decision making. And next we have AI categorization of this AI problems. AI needs to handle different types of problems. Those are structured problems, unstructured problems, linear problems, and non-linear problems. The structured problem where the goal state is defined. So, for example, pathfinding in maps. Unstructured problems, the goal state is unknown here. So, for example, diagnosing diseases. And linear problems, so based on dependent variables, for example, predicting stock prices. Non-linear problems where no dependency between the variables. For example, just weather forecasting. Okay. So next is before that we'll see what is that is the well structured problems and the ill structured problems. So well structured problems where we have a clear steps to reach the solution. For example, solving a Sudoku puzzle. Okay. Whereas ill structured problem is there is no predefined steps. For example, creating a new product design, which comes under the ill structured problem. And next, if you see those are top AI techniques which helps in learning from the data, that is machine learning, understanding text and speech, that is natural language processing, where it is NLP, and we have recognizing images, that is computer vision, and planning and decision making, for that expert systems we use, and prediction and forecasting, it is deep learning. Okay, so where we have several applications of AI. So AI is used in various industries, like for healthcare, the diagnosis, the disease, robot assisted surgery, and in the case of finance, fraud detection, stock market prediction, manufacturing, automation, quality control, transportation to the self-driving cars, traffic optimization, and for entertainment, movie recommendations, video game AI. Okay. So generally, what will be the problem in AI is that it is a space of all possible solutions where each state represents a step towards a goal. So key components of AI problems is that it's a state space, that is the possible configurations of a system is the state space. And where the problem begins is the initial state. The desired outcome will be the goal state. Actions that move from one state to another is the rules or the operators. And finding the best path from the start to the goal is the search process. Okay, for example, we have a state space example as tic-tac-toe. So each move here creates a new state. The goal is to arrange 3 symbols in a row, column or diagonal. AI analyzes possible moves and selects the best one. Okay. So this is the tic-tac-toe problem where there's search space. And next is the 8 puzzle problem where we have a state space example as 8 puzzle problem. Here a 3x3 grid with 8 tiles and 1 empty space has been. The goal is to arrange tiles in order. Here explores possible moves to solve the puzzle. So to here total possible states will be 8 factorial, which is 40,320. Right. So generally what is search? It is a method to find the best path in state space. The path can lead to a solution or a dead end. Okay. So there are types of search. First one is the forward search and the backward search. So first one is forward search, which is data directed. Starts from the initial state and moves towards the goal. For example, finding the shortest route, that is on Google Maps. Next, backward search is the goal directed one. It starts from the goal state and moves backward to find the initial state. For example, planning how to reach a destination from a known endpoint. And next we have informed search, which uses heuristic. That is what is heuristics is the common sense rules to guide the search. For example, we have A-star algorithm in gaming AI. We'll explore that in later. An uninformed search technique, it explores all possible states without prior knowledge. And for example, we have a breadth first search that also we'll explore later. And how do we evaluate a search algorithm is that based on the completeness, can it always find a solution, and it has a time complexity, how long does it take, space complexity, that is how much memory that does it need, and optimality, that does it find the best solution, and what is admissibility, is the solution logically correct or not. So thank you.